Okay, we're going to move on to section 5 and 6 of chapter 3, and we're going to do those two sections together. The topic of these sections is writing ratios, writing proportions, and then solving proportions. So the first thing we're going to focus on is reading and writing ratios in multiple representations. The second thing we are going to focus on is writing proportions that represent real world problems. That means we're going to be doing some word problems. And finally, we're going to solve proportions using the cross products property. Okay, so let's talk about vocabulary first. So what is a ratio? Well, we talked about this in the beginning of the year. A ratio is a comparison of two different things, two different quantities, using a fraction. So we do need to know how to read and write ratios in multiple representations or multiple formats. The first one, we'll say that we're going to read this, the ratio of A to B. That's just kind of in English, the ratio of A to B. We can also look at a ratio being written as A colon B. So that is read exactly the same way, A to B. And then finally we could look at it as a fraction, the ratio of A to B. Okay, so all three of these are read as the ratio of A to B. All right, now let's take a look at proportion. What is a proportion? A proportion is an equation, first of all. It has an equal sign in it, so it is an equation that arises when two ratios are set equal to each other. So a proportion is an equality of ratios. Here we have one ratio, 2 to 7, equals x to 35. You could also read that as 2 is to 7 as x is to 35. We should probably write that down. That equals is read as. All right, now how do we take a look at how we could solve for that unknown? Well, if we didn't know the cross products property yet, or we didn't remember it, we can look at what do we need to do to get from 7 to 35? Well, we can multiply by 5. If we multiply the bottoms there by 5, then we would have to multiply the numerator by 5. So 2 times 5 is 10. And we would call those equivalent fractions. 2 sevenths is equivalent to 10 35ths. All right, now let's take a look at a couple of examples of ratios and how we translate the English into symbolic notation. Okay, so the first example, a person makes 6 long-distance telephone calls and 15 local calls in 1 month. So the first prompt is to find the ratio of long-distance calls to local calls. Okay, so the first phrase that comes upon us in the sentence is long-distance calls. That order is important, and the long-distance calls have to go in the numerator. So we've got 6 long-distance calls, 2, and we would represent that with a fraction bar, the local calls, and the local calls here is 15. So we would write 15 local in the denominator. Likewise, we can also write it 6 colon 15. Okay, now we're asked, find the ratio of the long-distance calls to all calls. Again, the order is important. The first phrase is long-distance calls. That means that's going to be in the numerator, 6 long. And the total number of calls, well, we've got 6 long, 15 local, that's a total of 21 total calls. So we can write our ratio is 6 to 21 or 6 to 21. Okay, let's try another example. Example 2. Find the ratio first let me read the prompt here. Sean and Kelly are selling tickets to their school's talent show. Sean, and I have a misspelling here, Sean sold 36 tickets and Kelly sold 44 tickets. The prompt is find the ratio of the number of tickets Sean sold, that came up first, that phrase, that means that's the numerator, to the number of tickets Kelly sold. Sean sold 36, so we would put 36 in the numerator. And how many did Kelly sell? 44. So we can write that as Sean 36 to 44. You could also write it 36 to 44. And this particular ratio can be simplified. Both are even numbers, so we know we could simplify it by 2. 36 divided by 2 is 18. 44 divided by 2 is 22. Again, two even numbers. We can continue to simplify. 18 divided by 2 is 9. And 22 divided by 2 is 11. So it's always a good idea to put ratios in the simplest form you can. And what does this mean? That means for every 9 tickets that Sean sold, Kelly sold 11. And again, it's always a good idea to simplify. So we were just going in the process of simplifying each of those numbers. Okay, now we're asked to find the ratio of the number of tickets Kelly sold to the number of tickets total that were sold between the two of them. So Kelly sold 44 tickets. That phrase came first, so that needs to be in the numerator. And the total number of tickets sold were 36 and 44, so we need to add those two together. And we have 80 tickets total. Again, it's a good idea to simplify. We see that both the numerator and denominator can be divided by 4. So I'm going to divide 44 by 4 and get 11. And I'm going to divide the total number by 4, and I'm going to get 20. So what does this mean? Out of 20 tickets sold, 11 of them were sold by Kelly. Okay, now let's talk about the cross products property. We're going to be using this a lot. The cross products property is something that helps us solve for an unknown that's within a proportion. The cross products property of a proportion are equal. That's the main thing. So what does product mean? Products or product is multiplication, or the result of multiplication. So remember that. So if we have a proportion over here, A is to B as C is to D, well then if this is true, we can cross multiply, cross products. I'm going to show that with these butterfly wings. So A times D, and I have a typo here, so I'm going to ask you to completely cross this out. A times D, that product, is equal to B times C. So you're basically multiplying up here B times C and A times D, and they are equal. Those are called the cross products. Very helpful when solving proportions. So let's take a look at 3 examples. We have x is to 15 as 3 is to 5. Well, some of you, not even knowing the cross products, may see the relationship here. 15 divided by 3 is 5. Actually, I'm going to go in the reverse. I'm going to say 5 times 3. This way, 5 times 3 is 15. So 3 times 3 is 9. That's one way to solve it. Another way is to use the cross products. So I'm going to rewrite the problem. X over 15 equals 3 over 5. And I'm going to cross multiply. X times 5 is 5x. 15 times 3 is 45. And I see that x is being multiplied by 5. How do I undo multiplication? With division. I'm going to undo that with the inverse operation. 5 divided by 5 reduces to 1, and x equals 9. In this next example, here you see it's not easy, well, 12 is not evenly divisible by 8. So using the cross products is actually very convenient here. So 12 times x is 12x. 6 times 8 is 48. Now I'm going to undo this multiplication with division, and x equals 4. And finally, on this last example, if you have an expression up here in the numerator, something more than just a number or a variable, remember when you cross multiply, that 12 is multiplying the entire sum of 6 and y. So we have to put that sum in parentheses. And 6 times 2 is 120. In this case, then, we're going to have to use the distributive property. 12 times 6 is 72. 12 times y is 12y equals 120. I'm looking at my PEMDAS again, bottom up. And I see that I have addition of 72, and I have a multiplication of 12. I'm going to get rid of that 72 first, bottom up, and they cancel. 12y comes down, equal sign comes down, and I have 8 and 4. Now I'm going to undo that multiplication with division, and y again equals 4. Okay, let's take a look at a real world problem. We've got a problem regarding a scale model. It's kind of like an airplane model, but in this case, we've got a model of a building. So an architect creates a scale model of a school. The school is 50 feet high in real life. The ratio of the model to the actual school is 1 foot to 75 feet. Estimate the height of the model. Okay, so let's set up a ratio. We've got the ratio of the model to the actual school. So we want the model up on top. So we've got 1 foot model, that ratio, to 75 feet. And that's the actual building. And we're going to set up a proportion. We're being asked for estimate the height of the model. Now, since we put the model up on top here in the numerator, then the model has to be on the top over here. We don't know what that is, so we're going to assign a variable, but we do know that here we've got the actual building on the bottom, 75 feet, and we're told that the building is 50 feet high, so we're going to put that 50 feet actual building here on the bottom. Now we're going to cross multiply, and we have 50 times 1 is 50, and 75 times x is 75x. I'm going to undo that multiplication of 75 with division, and I have x equals 50 divided by 75. I'm going to simplify that a little bit. Both of them are divisible by 5, so 50 divided by 5 is 10, and 75 divided by 5 is 25. I'm going to further divide by 5. 10 divided by 5 is 2, and 25 divided by 5 is 5. And I'm going to even further put that into a decimal. 5 goes into 2 0 times. I'm going to put my decimal up there, carry down the 0. 5 goes into 24 times. So x equals 4/10, and that is, don't lose sight of what your units are. That's in feet. So 4/10 feet is the height of the model that represents a 50-foot high building. Thanks so much for listening.